Math 113, lesson 7-6 covers vectors. All right, so vectors essentially look like array. That's what they look like. The difference in an array and a vector is array continues in one direction forever, but a vector does have a terminal point. It has a stopping point. So our vector has an initial point and it has a terminal point. Array would not have a terminal point, but if you draw them, they look very much the same, but a vector has a terminal point. Another thing that's true about all vectors is they have both magnitude I did not spell that correctly, I'm sorry. They have both magnitude and a direction. Now when I say that word magnitude, what I'm actually talking about there is a length. Okay, magnitude is some sort of length, and a direction would be exactly what it sounds like, the direction that it's going. So our magnitude, since it is talking about a length, it's not going to be a negative value. So the notation for a vector is a lowercase bold. It's hard for me to do on this screen. So that would represent the vector PQ. So if this was my initial point was P, my terminal point was Q, then this would be my vector. Now if I want to talk about the magnitude, the actual length of my vector V, then the notation for that is we use these two bars, and that means the magnitude of, and that means how long is it. All right? So these points P and Q, if we think of them as ordered pairs, they would be two different ordered pairs. All right? And I could find the magnitude, which is the length, just by doing the regular old distance formula. Okay, so we are going to be using just the distance formula. So the magnitude of PQ in this diagram would be the square root of, and just as a reminder, the distance formula. There is our distance formula. Okay? So that's just the basics of our vectors, and so let's jump in and try to work some problems using this little bit of information to get us started. All right, so I'm going to draw for you a graph, and I'm going to put us a vector on there in a specific location. So this point is the order pair 3, 3, and I'm going to use this as my terminal point, -2, 1. All right, so there's my vector V, and what I want us to do is I want us to find the magnitude of that vector. Okay, so that just means the length, so we use the distance formula. All right, so y minus y squared, I'm sorry, my formula up there, I wrote x minus x first, so as to not confuse anyone, that's what I'll do. X minus x squared plus y minus y squared. All right, this minus negative is really a plus 2, so that would be 5 squared plus 2 squared. And I get the square root of 29. All right, that would be my magnitude, which represents its length. Now, when you're doing your magnitude, make sure you pay attention to My Math Lab. If they ask you for a decimal, then you would actually do the square root of 29, but most often they are not going to ask you to do that. You're just going to give your simplified radical. This radical won't simplify, but you would give a simplified radical. Okay, So a couple of basic things we need to talk about are I and J. I is the unit vector along the positive x-axis. And J would be the unit vector along the positive y-axis. So if I draw myself my x and y axis, and I have this vector v. Okay, let's say that this represents my vector v. It has an initial point, it has a terminal point, right? And we're going to name this point for the moment A and B. And so since I said our unit vector goes along the positive x-axis, and then our unit vector would go along the positive y-axis. Oops, that would be a J. All right, then this is how we would think about that. Actual vector V is AI plus BJ. All right, so that would be our unit vector, AI plus BJ. A and B, they call those components of our vector. So just making sure we understand the terminology here. And to find the magnitude of our vector, all we have to do is, again, we would say the distance formula, but in this case, since the origin is one of our points, we just have to do the square root of a squared plus b squared. The square root of, and we use the components in there. So let's use this information to help us with example number 2. We are going to sketch vector v, 3i minus 3j, and then we are going to find its magnitude, which is just its length. All right, so I'm going to draw my x and y axis. So my components, remember those are A and B. And so our A value and our B value are sitting right up there. My A is 3 and my B is negative 3. Okay, because if you look above, I defined for you the vector is AI plus BJ. Okay, since this is a minus, that means your B value is a negative. All right, so there are our components, 3, negative 3. And so that would be the ordered pair, 3, negative 3. That would be our terminal point. Those are our components, A and B. So this would be our vector. Okay, so there's the graph. And now it says find the magnitude. Okay, so this is the notation for magnitude. And we would take A squared plus B squared. We get the square root of 18. Now this is where I want you to simplify the radical. The square root of 18 is 3 on the square root of 2. Don't give a decimal there. Give your simplified radical. So there would be our magnitude. Okay, not too bad. These vectors set us up for being able to do physics problems, which we are not going to do physics problems, but that's really the whole purpose of vectors. All right, now let's talk about vectors in our rectangular coordinate system. So we talked about A and B are the components. Well, to find A, let's say that initial was not at the origin, and then we would need to know, well, what are my components, A and B? Well, you find your components A and B by subtracting the x values. You find your component B by subtracting the y values of your initial and your terminal points. So if P is my initial point, let's call it P1, we'll just say they're points, and my second point is my terminal point, now I would be able to find components even though one of my points is not the origin. My initial point is no longer the origin. So this is how I would find my components. So subtract the x's to find component A, subtract the y's to find the new component B. All right, we're going to let V be the vector from this first point, -1, 3, to this second point, 2, 7. That is our vector. What I want us to do is let's write our vector in terms of I and J, the unit vectors. So this up here is what our goal is. Okay, we're going to write the vector in terms of I and J. Okay, remember we said to find the A component, we subtract the x values. So 2 minus -1, that would be I, plus 7 minus 3, J. And now we just do that. So 7 minus -1 would give me 3I plus 4J. And there we go. We have written it in terms of I and J. So simple. Now, we can do things with vectors like we can add them, we can subtract them. We can do all sorts of things with our vectors. We are not limited to what we can do with vectors. So let's say I have two vectors that are in this form. All right, so if I've got those two vectors and I want you to add vector V plus vector W. Okay, well when I add the vectors, I have to add their like parts. So I would add the component A's, and then I would add the component B's. In this case, it would be 4 minus 7. Right? So I get 5I minus 3J. And that would be my sum. That would be my new vector. 5I minus 3J. We could subtract vectors, and we would do those the same way, being careful with our signs. Scalar multiplication, all that means is that you can multiply a vector by a number. So let's say we have vector V and it is 7I plus 10J. And I want us to find 8 times the vector. Well, in this case, 8 would be our scalar, and we are multiplying 8 times our vector. So 8 times our vector would be 8 times the 7I plus 8 times the 10J. So I get 56I plus 80J. Okay, you literally just multiply both components by the scalar. There is such a thing as a zero vector. A zero vector has a magnitude of 0. That makes sense. And here's what it would look like. The zero vector would be 0I plus 0J. That would be our zero vector. Those unit vectors, I and J, that we were looking at earlier, all unit vectors have a magnitude of 1. Okay, all unit vectors have a magnitude of 1. And so we sometimes are asked to find a unit vector that has the same direction. Oh, that is the word same. As some other vector that is given to us. All right, and so here's how we would do that. If we are asked to find a unit vector that has the same direction as a given vector v, then this is the formula we're going to use. We're going to take that vector and we will divide by the magnitude of that vector. And that produces for us a new vector that's the same direction as vector v. Okay, so let's apply that. Find the unit vector in the same direction as, I'm going to give you a vector, 4i minus 3j. And then when we're done finding it, I want us to verify it has a magnitude of 1. Okay, and that's going to be at the end of the problem. All right, so we're finding a unit vector in the same direction as v. Okay, so we use that little formula above, v over the magnitude of v. All right, so v is 4i minus 3j. Its magnitude, remember, we take a squared plus b squared, and then we take the square root of that. So that would give me the square root of, excuse me, 16 plus 9 is 25. And then I can actually do that, and I get 5. All right, so here's how we need to write that. We need to write them individually as component A and component B. All right, so there is our new vector. Okay, that's our new one. It's a unit vector in the same direction as v. Now, the next thing we were asked to do was verify that it does have a magnitude of 1. So we're going to take this new vector and we're going to verify its magnitude. All right? So magnitude would be, you take the A component and you square it, plus the B component and you square it, and then we'll take the square root of that. So I get 16 over 25, 9 over 25, which gives me 25 over 25. Whoops, did not mean to make that disappear. So I end up with the square root of 1, which is 1. So we have just verified that its magnitude is 1. All right, so making sure you do all the parts the directions may ask us for. All right, they're going to add another little specific set of directions, and it would say something like, write a vector in terms of its magnitude and direction. Write a vector in terms of its magnitude and direction. In other words, somehow we have to be able to see the magnitude and the direction in the problem. So let's make sure we understand what a direction is. So the direction angle, okay, because they will all have some sort of direction angle. That is an angle that our vector makes with the positive x-axis. So that's the angle that they're talking about, the angle it makes with the positive x-axis. Now typically our vector, we have it in this component form. All right. Now all that does for me is tells me the components in my graph, which would be like an ordered pair for me to graph. That doesn't tell me anything about the angle, nor does it tell me about the direction. The magnitude. So I need to have some sort of way to find those two pieces of information. Well, I already know how to find the magnitude. All right, I already know how to find the magnitude. That is not new. Okay, so I know how to do that part. What I don't know how to do is find that direction angle. So we're going to use this little piece of information. The cosine, our component A is found by taking the magnitude and multiplying by the cosine of theta. Our component B is found by taking the magnitude and multiplying by the sine of theta. Now, if you think of this as our components A and B, like an ordered pair, X and Y, this should make sense. All right? So, if we are writing our vector in terms of magnitude and direction, then I'm going to change A to be magnitude of V cosine of theta, I. And then I'm going to change B to be magnitude of V sine of theta. And then I have my times J. So this would be my vector in terms of magnitude and direction. This is component form. We've got our components A and B. And then the other one that we have down here at the bottom is our magnitude and direction. So let's try to use that information to do our last example here. We are going to write our vector V in terms of I and J, whose magnitude is 14 and direction angle is 150 degrees. Okay, well that's great because it gave me the magnitude and the direction angle. All right, so our magnitude and our direction angle. We have them. Awesome. So I have to magnitude times the cosine of 150, I, plus magnitude times the sine of 150, J. Now, we can't leave it like that. That's just how we get it started. Now we actually do the cosine of 150 and the sine of 150. Those are on our unit circle. The cosine of 150 is negative square root of 3 over 2. The sine of 150 is 1/2. Those are on our unit circle. So now I simplify and I get negative 7 on the square root of 3, I, plus 7, J. There we go. They're in terms of I and J. We have used our magnitude and our direction angle. All right. If you have any questions, please email me. This is the last section. Actually, I think there's one more section that we have to cover in Chapter 7, and then we will be finished. I think there is one more section. So be looking for that. And if you've got any questions, please email me.